All right, welcome. This is section 4, the last section for this chapter. We're taking a look at Earth's moon. The PDN is a review from oh, the previous two parts where we looked at the orbit of the Earth, the moon around the Earth, how long it takes. So, how long does it take the Earth to go around the Earth, to revolve around the Earth? And question number 2, how long does it take the moon to rotate on its axis? I'll give you a little hint. This answer is the same for both questions. All right, today we're going to be talking about the moon itself. First of all, the Earth's moon includes craters, highlands, and maria. Now, that's not Maria, it's a Latin word for sea. Okay, craters, highlands, and maria. All right, now astronomers going back all the way to Galileo. Galileo was one of the first scientists ever to point a telescope at the things in the sky. Telescopes had been around for a while before that, they had been used at war. Galileo turned around and started using telescopes to look at the sky. You might know of Galileo from history class because he was the one who had said that the Earth revolves around the sun instead of the other way around. He looked at the moon. He took many observations of the moon and he described what he saw there. He saw these round pits that he called craters based off of volcanic craters. He thought they were volcanoes. We know today that they're not volcanoes, that they're caused by asteroid impacts, but he called them craters and he named some of the craters. He also saw areas that he called highlands that looked like mountains, and they essentially are mountains. And he also saw what he thought were dry seas where there had at one point been water, but it had dried up. He called them seas, and there was a very large one he actually called an ocean. If you look on this picture, this is a picture of part of the moon, and you have different parts of the moon that are labeled. Mare Frigoris is what he called the frigid sea. It was towards what would be the North Pole of the moon. Lacus Seminorum, sorry if Somniorum, sorry for my Latin terrible pronunciation. That is Lake of Sleep, I think. I'm not perfect on my trying to translate Latin. He named a lot of the different. Hold on, just a second. He named a lot of the different parts of the moon, the craters, after famous people that he knew of, either from mythology or from history. Aristotle, Atlas, Hercules, Eudoxus. Uh, so he named a lot of the different features on the moon. So all of these are features that he saw with the telescope. Craters, they're round pits, they're formed by meteorite impacts. Galileo thought that they were uh, the remainder of ancient volcanoes. He was wrong in that part. We know today that they are formed by meteorite impacts. Next were highlands. These were mountainous areas, higher portions of the moon. It's left over from when the moon was formed. And finally, Maria. They are dark, flat areas. They are ancient lava flows. These are areas that are really old from the formation of the moon. They are fairly smooth, they're dust covered, but they're smooth because it's ancient lava. It was once thought to be ancient seas that had dried up, but we know now that that is wrong, that they are just smooth areas, they're lava flows that have not been impacted by craters. Um, I talked before about how the near side of the moon has a whole lot less craters than the far side of the moon. The far side of the moon is completely covered in craters. It's crater upon crater because the not as many meteors impact the near side of the moon as impact the far side of the moon. Uh, Meteor impacts on the moon last a lot longer. Those craters that are still around have been there a lot longer. The reason that they are able to be seen for a long period of time is they don't get worn down. We would have even more craters here on Earth than they have on the moon, except we have wind, we have rain, we have plate tectonics, all these things that wear away our craters over time. Eventually, the craters just are no longer there. The plate that they were on is absorbed back into the mantle. The moon does not have plate tectonics. So if a crater, and it doesn't have an atmosphere, there's no rain, there's no wind, nothing to wear down a crater. So when a crater happens, it stays on the moon. So the moon looks like it's had a lot more meteor impacts than the Earth has, but it's had a very small number compared to what the Earth has. The Earth, if it had the same airless and uh, no plate tectonics condition that the moon has, we would be completely covered in craters as well. The reason we can see so many is because no air, no no geological movement. All right. Uh, there are many different seas that they had named. Oceanus Procularium, Ocean of Storms, Sea of Tranquility. You may know this Sea of Tranquility because that was where the first human landing on the moon occurred. That's where Apollo 11 landed. Other landings for the Apollo missions landed elsewhere on the moon. All of the moon landings, though, happened on the near side of the moon. The reason for that is the only way they could communicate with the Earth was through radio broadcasts, and there were no satellites going around the moon to relay it, so there was no way they could be on the far side of the moon. So all of the communication had come from the near side of the moon. All right. You can see some of the highlands down here. All these are lava flows, ancient lava flows. All right. Some characteristics, some facts about the moon. The moon is much smaller than the Earth. It's 1/4 of Earth's diameter. So it is 1/4 across from, you guys know the diameter of a circle. Its diameter is 1/4 what the Earth's is. It is 1/80th of Earth's mass. That's a combination of the square cube rule and also the fact that the moon is made up of much less dense materials than the Earth is. The Earth is much more dense. Because of that, the moon's gravity is much smaller than 1/4 of Earth's gravity. The moon's gravity is about 1/10 of Earth's gravity. So the size and density of the moon is much smaller than the Earth. This kind of question may show up on your quiz. I think I may ask you about Earth's diameter. I don't think I'm going to ask you about I'm sorry, the moon's diameter, not about the moon's mass. Temperature. Now, the moon has no atmosphere, so because of that, the temperature varies a great deal. The part of the moon that has been in sun, now remember, how long is a moon day? 27.3 days, same as the amount of time it takes the moon to go around the Earth. So, in that 27.3 days, half of it, about 13.65 Earth days, 13.65 Earth days, it is in full sun with no atmosphere to break up the light. So at the end of a moon day, the temperature on the surface of the moon gets very hot. It gets up to 130 degrees Celsius. Now, at the end of a moon night, remember it lasts just as long, 13.65 Earth days, it is a negative 180 degrees Celsius. That major temperature variation has to do with the length of the day and the fact that there's no atmosphere on the moon. As soon as the sun stops shining, all of that heat is lost into space. Space will cool down the surface of the moon very, very quickly. All right. A big question that we are still researching today, something that we really want to know is whether there is water on the moon. There, there is absolutely no liquid water. Those Maria, those seas, are lava flows. There has never been any water in those, what we call seas. Uh, there has never been any water. There may be some ice. The only place where there could be ice is towards the north or south pole of the moon, you see these craters towards the poles? There are places in those craters where the sun never shines because the rim of the crater keeps the entire area in shadow. And those craters were formed by the impact of meteors. Some meteors are basically giant snowballs. They're mostly ice. So if the moon was impacted by a meteor like that, there may be some ice in the North Pole and South Pole. That could be extremely useful for us humans if we ever decide to make a moon base. Water is very heavy. It's very difficult to transport. If we ever wanted to have a moon base, it would be much easier to get water from the poles and use that on our moon base than to bring the water all the way from Earth. All right. How do we think the moon was formed? We don't know for sure. But our best theory, the best way that we know to explain the origin of the moon is what's known as the collision ring theory. This is our best idea. Now, we think it happened through several steps. First, there was an impact. About 4.5 billion years ago, planet Earth had just formed. The solar system was still in the process of forming. We think that there were more planets at that time that eventually came together to form the planets that we have today. Earth was struck by a planet-sized object about half to a third the size of the current Earth. We think these two objects struck. Both Earth and this other object were mostly liquid at that time. Even our surface was still mostly molten. It hadn't cooled enough to form the plates that we have today. Those two objects struck, and that the most of what was that planet-sized object that struck the Earth stayed together. However, that impact and the combination of those two objects was enough to throw a bunch of debris, a bunch of loose rock, a bunch of liquid molten rock and droplets. Some of these droplets would have been city-sized, but still it would have thrown this into orbit. We think for a short period of time, Earth had a ring of molten rock and rock around it, and that ring slowly formed into what is today the moon. The moon has cooled much more quickly than the Earth has, and it has it is much less dense. That's why we think this explanation is the most likely, because the density of the moon could be explained if it had come from the outer layers of the Earth. Remember, the core of the Earth is made out of molten metal, nickel and iron, which is much more dense. The outer layer of the Earth, the mantle, is made out of liquid rock, which is less dense. The density of the moon matches up with the density of rock, not with the density of metal. So we think that these two objects left all of their metal in the Earth, and that the molten rock that was blasted off formed what is today the moon. So 4 steps we have here. A planet-sized object hit the Earth. Material from the Earth's outer layer, what would be the mantle, and the beginningest formation of the crust. Remember, it was still hot at that time. It was not solid at that point. This material was thrown into orbit, and it formed the moon. All right, we got some questions for you to answer on the back. Name the 3 major features of the moon's surface. Those 3 features are craters, maria, and highlands. Craters, maria, and highlands. Make sure you write down all these answers. If I go too fast, remember, you can always pause these questions. Next, how did the moon's craters form? From meteoroid impacts. Galileo thought they were volcanoes. Galileo was wrong. Meteoroid impacts. Why is the moon's surface much more heavily cratered than Earth's surface? It's not because the moon's been hit by more meteors. It's because on Earth, they have things that weather those craters down. Those craters slowly disappear on time. On the moon, they always stay. Water, wind, and other forces wore away craters on Earth. There is no wind or liquid water on the moon. So there's no way that the craters on the moon could disappear. So what is the range of temperatures on the moon? It gets much hotter than on Earth and much colder. The top temperature is 130 degrees Celsius, and the low temperature is negative 180 degrees Celsius. Guys, remember, water boils at 100 degrees Celsius, so that's hotter than boiling. All right, and that's more than 180 degrees colder than freezing. Zero is where water freezes. So that is more cold, much more colder than freezing. It's about the difference between freezing and boiling. It's about 3 times that, but towards the negatives. 100 negative 80 degrees Celsius, uh, carbon dioxide starts to form into dry ice. So in Fahrenheit, if you need to know, that's 266 degrees Fahrenheit to negative 292 degrees Fahrenheit. So what's the relationship between the moon's surface, gravity, lack of an atmosphere, and temperature range? All right. So the moon has less gravity. I forgot to talk about this, but I can talk about it now. The moon has less gravity. Because the moon has less gravity, it's not able to keep an atmosphere. Any gases that are around the moon escape into space. It doesn't have enough gravity to hold it down. So over time, any gas that's released on the moon would go straight into space. There's the tiniest bit of an atmosphere, nowhere near anything that somebody could breathe. Because it doesn't have an atmosphere, that's why the temperature changes so much. Earth's atmosphere kind of acts as a blanket for it. It insulates the surface from space. So when it's nighttime, it does not get nearly as cold as nighttime on the moon does. So the lack of an atmosphere. So because there's no gravity, there's no atmosphere. Because there's no atmosphere, there's a huge difference in the changing temperatures on the moon. All right. Ooh, I don't think I talked about this one either. What was the solar system like when the moon formed? It was full of rocky debris. More it was much more crowded. There were all the planets hadn't formed into what they currently are. They were all smaller. They've added to them over time. The gas giants had not absorbed as much as they currently are. It was a lot more gas and debris left over. It was stuff was still kind of solidifying. All right, the stages in the formation of the moon. I think I only put 3 on this one. I had put 4 on earlier. A planet-sized object collided with Earth. Material was ejected into orbit around the Earth and formed a ring. And gravity caused that material to combine into the moon. All right, that's the end of the slideshow. I think I'm going to put a question on your little quiz thing just so that to see how many people actually go to the very end of this video. It's going to be a bonus question. The answer to the bonus question will be 17. So just the number 17, and you will get an extra point because you listened all the way to the end. Thank you.